The Rock Lighthouse, one of the most heroic feats of engineering in maritime history.
You're out there fighting the elements, you're fighting nature on the front line.
Built to save the lives of thousands at sea.
There was a lot of shipping lost.
In the face of catastrophic storms.
The day you turn your back on the sea is the day you're going to die.
So how did they build them?
Whoa!
I'm Rob Bell, and I'm going behind closed doors to uncover staggering tales of innovation, epic adventure.
This is over 300 degrees, this lead I've got in here, right?
And danger. To reveal the secrets of some of the most extraordinary structures ever built. This time, Britain's unluckiest lighthouse.
It was just a disaster waiting to happen.
3 towers smashed by the sea, consumed by fire, and defeated by jagged rocks. How did one finally stand up to the waves when so many had failed?
It's really heroic what those men did.
This is a story of audacious engineering and geniuses who achieved the impossible.
Fantastic.
All in the midst of Britain's most unforgiving seas. The Eddystone Rock Lighthouse. The English Channel off Britain's southwest coast is a graveyard for thousands of shipwrecks.
I'm following in the 300-year wake of 2 ships that set out through these waters in 1695, but neither would ever make it home.
These merchant ships, the Snowdrop and the Constant, were to kickstart a chain of events that would save thousands of lives. But they'd pay for it on the area's deadliest hidden secret, the Eddystone Reef.
This jagged reef of low-lying rocks rises straight up from the deep. And when these lethal arcs of spikes were all exposed at low tide, sailors have said they look like crocodiles' teeth. And that August, some 300 years ago, the Snowdrop took 60 crew members down with her. And just 4 months later, the Constant was also claimed by the Eddystone Rocks.
An architect who's said to have had shares in these ships had an idea to put a stop to the endless losses on these treacherous rocks.
He vowed to build a tower with a warning light on top of these rocks, out here, 9 miles from land. But not only a warning light, his tower would also be able to house people 24 hours a day, 365 days a year. He was talking about the world's first rock lighthouse.
And what rocks they are. Being the entrance to Plymouth, the home of British maritime might, they were claiming countless ships, bringing supplies into port, heading out to explore the new world, or sailing into battle. Shipping was booming in the 1600s, but Plymouth's trade, livelihood, and even the Royal Navy stood to be crippled by the Eddystone Rocks. The reef had to be tamed.
The man who started it all in 1696 was Henry Winstanley. But he wasn't a salty old sea dog, nor was he a calloused engineer. He'd made his name as a showman. A wealthy student of Sir Christopher Wren, he built a water attraction in London's Hyde Park. And he was known for having a particular fondness for playing flamboyant practical jokes. No wonder then when he first proposed building an inhabitable tower way out at sea, people just laughed.
Winstanley would have been perceived as attempting the absolutely impossible, but he was also someone with a flair for wacky ideas, which I think is a very critical qualification for building rock lighthouses. So he had designed playing cards, he had opened a museum of moving robots. And he had to transplant the knowledge that had been gained through centuries of land-based architecture and somehow make it work on a wave-washed reef miles off the coast of Plymouth.
By the 1600s, lighthouses had already been built all around the world, on land. The go-to construction material for strong, solid buildings of the age was masonry, brick or stone held together with a lime mortar. Now, that combination works absolutely brilliantly on land, as many an historic building can testify. But at sea, lime mortar has a fatal weakness. Let me show you. Right then, I've come armed. Now just bear in mind, even if I get in really close to the wall, the water coming out of this high pressure nozzle still won't match the kind of forces and pressures exerted by the waves crashing from an angry sea. Right, let's see what happens. Just look at that, it takes next to no time at all for this water to start blasting out that lime mortar from in between the bricks. Look at it go. It's almost too easy. Done. Oh, hey, there goes one. It's like scraping soft butter off of warm toast. Go on, this is going to go. Going, oh, yeah. And this one, look at that. Oh, the whole thing's coming down. You can see my point. If you were relying on traditional masonry like that with lime mortar to protect you against Mother Nature at her very angriest, I wouldn't fancy your chances. Whew.
I have no doubt about the power of waves, the power of the sea, and it's a deadly environment. You cannot imagine the power that a wave has, the power of the weight of water. It really is incredible. It's something you have to be very wary of all the time.
So what was Winstanley's solution to stand up to such mighty forces? He proposed building a tower comprised mainly of wood. The result was a bizarre creation, fit for the showman he was.
In 1698, the light was lit on the world's first rock lighthouse. Standing 59 feet tall, it housed 60 candles behind glass panes to warn sailors away from Eddystone Reef and allow them safe passage into Plymouth Harbour.
Winstanley built the first Eddystone Lighthouse, and it was very beautiful. It was made of timber. It was the perfect architectural construct, if I can put it so.
It was a strange and fantastical thing. It had a circular stone base anchored firmly into the rock. He used 12 iron anchors to really root the tower. And then above that rose this really fascinating superstructure of octagonal rooms and then an open gallery above with the lantern at the very top. And it was crazily decorated with ornamental ironwork and Latin inscriptions. There was a gilded bedchamber, which must have been amazing. You know, this was a building that could only have been built at the time by this one man.
Winstanley had succeeded in raising a light where none should be, and it was instantly successful at saving ships from Eddystone Reef. But in order to survive all year round against ferocious winter storms, an even stronger tower than the first was needed.
Winstanley's second reinforced tower basked in glory for more than 4 years. But one night in 1703, a massive storm, the likes of which no one had ever seen before, was bearing down on Plymouth.
The Great Storm of 1703 was the most destructive storm that Britain had known for centuries. Ships were shoved up estuaries, whole forests were felled. You know, this was no ordinary storm.
Winstanley, who was making repairs to his lighthouse as the storm set in, was about to have a long-standing wish granted: to be present in his tower during the greatest storm there ever was. At around midnight, onlookers from the shore reported seeing its candles being blotted out from view in the storm. The next day, the tower, its lighthouse keepers, and Winstanley were all gone. So who would be next to attempt the seemingly impossible? And how would they do it?
In the late 1600s, the sharp-toothed reef that was devastating Plymouth's shipping brought about the world's first rock lighthouse. Henry Winstanley's tower saved lives for 5 years, but in 1703, it was swallowed by the worst storm to hit Britain in centuries. Eddystone Reef was once again free to claim more victims.
So far, the construction materials of 300 years ago had failed to produce a suitable solution. Masonry was great for building on land, but would be torn apart by the sea. Wood was excellent for building ships, but too weak for a tall tower. But then a man called John Rudyard had a new idea. What about a tower that was half building, half ship?
Rudyard thought that if he could build a tower that was designed to bend when waves hit it, it could roll with the punches instead of being uprooted or smashed to bits. The bottom half of the tower was constructed with masonry, but sandwiched between layers of timber that would flex like a ship when waves hit it.
John Rudyard's was everything that Winstanley's tower was not. It was a circular structure instead of octagonal at the top, and that gave the waves no hard edges or straight, flat surfaces to hammer their impact upon. That became a principle that was used in all subsequent lighthouses.
The smooth, circular exterior was achieved by hiring boat builders to encase the whole tower in timber.
It was more like a ship than a tower in the sense that it was formed of overlapping planks like a ship's hull and was caulked with moss and tar to make it watertight.
But like every good ship, it needed an anchor. Rudyard had to do better than Winstanley if his tower were to stay fixed to the rock.
The foundations holding Winstanley's tower in place were iron rods that slotted down into holes chipped out of the rock. These rods were then set in position by pouring molten lead in the holes, which then solidified. But in the eye of that catastrophic storm, these were simply plucked out by the waves. Rudyard used the same principle of setting iron rods in the rock using lead, but added an ingenious twist.
To illustrate what he did, I've come to a traditional forge at Mount Edgecombe in Cornwall. Here, a mould replicates X-shaped holes that Rudyard cut down into Eddystone Rock.
It is the dovetail shape. It's that bow tie kind of thing that you see in woodwork. But it's great to see what the shape is underneath the rock, because I guess out on the rock here, you didn't split it open. They'd have had to have done that from the top.
Yep, drilled them out, ready for the lead to be poured in.
The two halves of the mould are clamped together, while the lead to fill it is melted on the forge.
Oh, it leaves you with a beautiful shimmering surface, doesn't it?
Pretty, isn't it?
Ooh.
The crucial difference with Rudyard's foundation rods is that they could be crossed tightly inside the rock to form an X.
Now, this is over 300 degrees, this lead I've got in here, right? I'm all right walking on this relatively flat floor inside the forge here, but just think about out on Eddystone Rock, slippery rocks, walking around with this stuff. There we go.
Nice and slow.
It's covering our rods there.
So we go to the top.
All the way to the top, yeah?
Yep, that's him. Perfect.
How about that?
That's it.
There we go.
Super stuff. And this designed for our foundation rods here with the dovetail-shaped cavity and the crossing rods within the rock. This is Rudyard's design for his lighthouse to improve on what Winstanley had, which were, I mean, similar kind of thing, you know, the iron rods into the rock, but a difference in geometry and the difference that can make structurally when it came down to it.
With the lead set around the rods, they form one solid X-shaped plug inside the rock. So can they be forced out?
Let's see how strong these bars feel.
Would you like a hammer?
Yes, please. Would I like a hammer? Of course I'd like a hammer, Mark. If I come across it, I mean, I'm bending the bar.
Yep.
You know, it's not that the plug's not the issue here at all.
The plug isn't moving.
That is rooted solidly into our rock here now. And these are the kind of forces that were difficult to protect against. Those transversal forces coming across. With these kind of foundations, at that angle, you'd be absolutely confident whatever you could connect onto here was going to be held down onto that rock. It's pretty clever, really, isn't it? I mean, it's a genius, because it's not a big difference from what Winstanley had done. Yeah. It's just about the geometry and looking at it structurally.
Yeah.
Using his impressive and at the time groundbreaking innovations, Rudyard's lighthouse was finished in 1709. Once more, ships had safe passage into Plymouth Harbour.
Rudyard's tower was a resounding success. Ports and shipping routes around Britain were desperate to build their own, but that would come at a daunting price. It had taken a small army of skilled craftsmen 3 years to complete Rudyard's lighthouse, working in dangerous conditions.
And the financial outlay was massive, gambling almost £2 million in today's money. But if Rudyard's tower stood for long enough, it could be a real money spinner. Since the time of Henry VIII, all lighthouses had permission to charge ships a fee for passing them.
Once you had a lighthouse, you got lighthouse dues. So every ship that passed your lighthouse at the next port it docked at, your collector would be there and you would be charged, so that's where the revenue came from.
Charging a penny per ton, Rudyard's tower would eventually make £1,000 a year, a small fortune at the time. But after almost 50 years of success, his achievement was about to go up in smoke.
It seems crazy to us now, but the lighthouse was lit by candles, and 60 of them burning simultaneously. And there was a dark and stormy night, and one of the candles tipped and set fire to something. One of the 3 lighthouse keepers, Henry Hall, was 94 years old. I mean, it just seems he was doing very well to get up and about, let alone go up and down stairs of a lighthouse. So there's all 3 of them trying to bring buckets of water up. But it gets to a point where it starts to melt the lead that's casing the cupola. And the worst bit for Henry Hall was that he was looking up and went, "Oh!" And of course, with his head back and his mouth wide open, this gloop of lead sort of went down his throat. But eventually, the fire becomes really devastating, and they decide to retreat to a bit of the rock outside until somebody comes to rescue them. Sadly, he died 10 days later, and not of old age, but obviously of the lead in his gullet.
On the 2nd of December 1755, Rudyard's entire wood-encased tower was destroyed by the fire.
So far, the battle to gain a foothold on Eddystone Rock stood at Mother Nature 3, man-made structures 0.
But then, a new contender stepped up to the challenge. In 1759, a gifted engineer named John Smeaton had an idea for a radical new shape with a daring choice of building materials.
He wanted to build a tower completely in stone and would neutralise the threat of the crashing waves by playing Mother Nature at her own game. This is something I'm quite looking forward to seeing that you've got here.
Amazingly, Smeaton produced a book cataloguing the whole design and build of his lighthouse.
How common is it for someone like John Smeaton to do something like this, to record all of the work and all of his findings and thoughts as he went through?
In these days, engineering was a very primitive profession, and for a guy like Smeaton, who was fundamentally an instrument maker, he wasn't a civil engineer. And to record what he did meticulously was part of his nature.
Now, this is a lovely page because...
That's right. Smeaton chose the English oak as his model, his inspiration for something that could withstand the forces of nature over hundreds of years. So he deliberately modelled the shape of the tower on the shape of the oak tree. And so you see this very beautiful curvature up the outside of the tower. So the idea was that the waves would run up the tower and then be diverted away from the lantern at the top.
And it was all about trying to disperse the energy, wasn't it? The energy in the water, dispersing that away.
Allowing it to find its own course rather than to bash sideways into the tower.
It's so clever and inspired by nature.
It's a very sensible shape, very effective. And it did, of course, produce the shape of lighthouses that we're all so used to.
At Plymouth University, their 21st century wave tank can test how Smeaton's oak tree shape will stand up to the biggest waves in the future. A scale model is subjected to extreme waves, the likes of which are only seen once every 50 years. But even in these conditions, Smeaton's design effectively directs the force of the wave up and around the tower. To see this in the real world, they put cameras and sensors in the current Eddystone Lighthouse.
We're looking here at the 4 cameras that were on the Eddystone Lighthouse, and we can see some footage of the wave run-up, and you'll see the waves coming in here and then moving up the tower. Some of these wave run-ups were sufficient to completely obscure the camera, and they had a run-up of up to 40 metres.
The most surprising thing they discovered was just how powerful the waves were that shook the sensors on the tower.
Some of the maximum impacts were a fraction of a G, and that's equivalent to perhaps, say, a very strong earthquake.
The classic oak tree curved lighthouse that was pioneered on the Eddystone Rock over 250 years ago has been copied around the world again and again and again. But how did they manage to build a stone tower out at sea in the first place?
Previous bold experiments in lighthouse building on the Eddystone Reef had either been uprooted by the sea or burned to the ground. In 1759, John Smeaton created a new shape that let the waves slip around it. But attempting to construct this mainly from stone would introduce a whole new challenge.
Smeaton had pioneered the tapering curves that were to become the classic lighthouse design. But previous experiments with masonry at sea had needed an extra layer of protection to stop the waves from getting in between the blocks and pulling them apart. So how did Smeaton's stone tower defeat Mother Nature?
He came up with this notion of stonework that dovetailed. So it wasn't just mortar connecting them, it was very substantial bits of stonework that interlocked.
What better place to illustrate Smeaton's game-changing stonework than a traditional mason's quarry near Bodmin Moor in Cornwall?
I've got here some conventionally cut rectangular stone blocks or bricks, and they're not too dissimilar in shape to house bricks, really, and they are very good at withstanding a vertical pressure, but they're not so good at withstanding horizontal forces. So, I mean, I can move these around quite easily here. There's nothing to stop them sliding around against each other. Now, by the very nature of where lighthouses are built, they're subjected to some fairly extreme horizontal forces. We're talking gale force winds and waves crashing sideways into the lighthouse. Now, the secret is not to cut rectangular blocks, but instead cut something a bit more like this, like large bow tie shape. It's a technique that's borrowed from woodworking. It's called dovetailing. So when you look at this pattern laid out here, there's no single straight line in any one direction for very long. So if I try and push along this here, you can see that it's very difficult. They don't want to move because there's no one plane, there's no one line for them to move and to shear alongside each other. That's the secret. It was all in the shape of the blocks.
For Smeaton's stonework to stand up to the waves, he chose some of the hardest granite available. But for dovetailed stones to lock tightly together, they had to be cut with utmost precision. So how did stonemasons achieve such crisp lines over 200 years ago? At Birator Quarry, the masons still use traditional techniques.
One of the best properties about granite is how hard it is. And that's great for when it's out in situ, but I'm assuming there's a kind of flip side of it. It makes it quite difficult to work, does it?
It's hard to work, but if you've got the right gear, you can make it a bit easier for yourself.
Because we were talking about tons and tons and tons of stone that went into building these lighthouses. Would all of that have been cut and shaped using hand tools at the time,
Yeah.
I'm guessing?
Yeah, nearly all of it.
We've got a block here,
Yeah.
Peter. Can you show me the kind of things that they might have been doing then?
To start to get the waste off,
So we're going to try and get rid of this?
yeah, we're going to get rid of that.
OK.
So they would have done that on a 3-ton stone.
Wow.
All right, so we...
Oh. I'm quite surprised at how much comes off with one blow there. Look at that. I'm amazed at how that's come away. I mean, that's done fairly quickly, but we're on a smaller scale here to the kind of blocks they would have been using.
They would have been days on one piece of stone.
When construction of the tower began in 1756, the huge stones were taken by ship to the reef and manhandled into place. It took 3 years to cut, transport and place over 1,000 stones on the remote and unforgiving site, constantly at the mercy of the sea.
Can I have a go, just to
You
see
can
what it's
certainly have a
like
go.
chiseling away at granite? Now, it's quite sharp blows you were giving it with that hammer.
Crisp, you want to show it who's boss?
Right, good. Just get a feel for this hammer before I start going anywhere near my hand with
It's
it
not
first.
light.
Right, so I'll place that on there. Ah, I wimped it.
That's all right.
OK, let's go again. I did, I wimped it with the hand. No, it needs to go hard, doesn't it?
There you go.
All right.
How's that?
That comes away well. Right. Oh, come on, you wimp.
There you go. You can see it going.
I'm a little over the line there.
That's all right.
Not quite as sharp as the edge you created,
No.
Peter, but we're getting there.
That's OK. We'll take you on as an apprentice. If it was a big block, a 3-ton block, which would be more than a cubic metre,
Yeah.
and you've got to take all that.
God, the amount of work that went into that masonry was unbelievable.
Incredible.
And times thousands of blocks.
Got to have a lot of respect for them, haven't you?
Oh, absolutely.
Yeah.
Absolutely.
On the 16th of October 1759, the light was lit on Smeaton's tower. After over 60 years of trial and error, heroism and tragedy, Eddystone Reef had finally been claimed by an outstanding man-made structure.
Smeaton had been the big breakthrough in lighthouse design, and all others have followed on from him.
The success of Smeaton's tower can be measured by the number of rock lighthouses that sprang up around the British Isles throughout the 19th century, every one made to the same shape and design. All lighthouses are overseen by Trinity House, an authority set up by Henry VIII in 1514 that still operates today.
This is the Operations and Planning Centre for Trinity House in Harwich. And from here we monitor all the lighthouses and the major buoys around our coastline.
Rock lighthouses are no longer manned, so this control room operates the 65 lighthouses in UK waters remotely.
95% of goods come into and out of the UK by ships. So it's really important to us as an island nation that shipping moves safely around our shores. The economy depends on it.
Even though sophisticated GPS navigation is now common on even the smallest vessels, Trinity House still maintains and keeps the lighthouses going as a navigational aid.
Lighthouses and all of our visual aids navigation are still really important today. The professional navigator is a little like a detective. They should use all available means to work out where they are and where they're going, and that their navigation is safe. So if satellite systems are not working correctly, and they're all vulnerable to either space weather or jamming or something similar, then actually our systems are the fallback to get them safely into port.
Whenever you are in a boat on the water, you're at the mercy of the winds and the tides and the swell and the sea, and that puts you off position. And the most important thing on any passage is to know where you are. And be they channel markers, navigation buoys, lighthouses, transit bearings from land, they're all vital to safe navigation.
But back in 1877, after protecting mariners for well over a century, Smeaton's tower came under threat.
Smeaton's tower wasn't to be the last structure to be built on Eddystone Rock. Mother Nature was about to find a way to reclaim the reef.
But this time, it wasn't the tower that was at fault. It was the rock it was built on.
In the latter part of the Victorian era, the Trinity House people had concerns about the reef itself, and they were worried that if the reef were to give way, that Smeaton's lighthouse might just fall into the sea through no fault of its own, but through the rocks underneath. So they couldn't risk that. So they commissioned James Douglas to build a taller lighthouse on another part of the reef.
In 1878, James Douglas began construction of the current Eddystone Lighthouse. Smeaton's tower was supposed to be dismantled before it risked collapse. But as any passing boat can see today, it put up a hell of a fight.
It is remarkable that the stump of Smeaton's original tower is still here after more than 260 years. I mean, ultimately, the lighthouse structure proved stronger than the rock upon which it was built. Whoa! It's no wonder lighthouses like this have remained a mystery for so long. Built to shrug off the sea, they're impenetrable to us too. Just look at its smooth walls tapering out of reach. And the top is often quite literally in the clouds. Even the entrance door is way up above ground level, if you can call it ground level. I mean, who can say they've never looked out at these stoic monoliths and not wondered what goes on inside those walls?
rock lighthouses are now sealed shut and unmanned. But there's one that still gives a glimpse of this secret other world. And I've been granted special access to explore it for myself.
Oh, this is brilliant to see.
Now that Britain's rock lighthouses are automated, the keepers are long gone. Inaccessible at the best of times, it now seems impossible to see for ourselves how those brave men lived and worked inside these fortress-like structures, except at Plymouth Hoe. Here, the dovetailed stones that the Victorians recovered from Smeaton's tower could be slotted back together so it stood proud again. Restoration expert Jason Hull has been charged with refurbishing it over the winter.
This isn't exactly how I'd hoped to come and see Smeaton's tower, because it's an iconic part of Plymouth skyline, really, isn't it?
It's basically Plymouth. When you talk about Plymouth, you talk about Smeaton's tower, you know, that's it.
So what exactly is the work that you've got going on here?
We're just doing a basic spruce up, giving it a refurb, basically.
And structurally, how is it? Is there anything that
Solid.
needed doing structurally?
It's absolutely solid.
Is it really?
When you consider where it's located and the amount of weather it gets. You know, when we put the scaffold up, we looked on the dome.
Yeah.
And to be honest, it's in perfect condition.
Properly built to last.
Yeah, exactly.
It's quite tight up through there, Jason. Look at this here.
Yeah, you can see where
Look how that's worn. There's a number of people come up through here. All right then. I wasn't expecting masses of space inside, but it's really pokey, and you get that feel all the way coming up, don't you, as well?
Yeah, claustrophobic, isn't it, a bit? Yeah.
So whereabouts are we here? We're a couple of floors up here.
This is the second storage area.
Yeah, OK. Yeah. The thing you notice about all the furniture in here, it's all rounded.
Yeah.
So it's all been designed and built to fit into the round space that you've got here. All right.
So here, Rob, we have the kitchen.
Fairly basic.
You've got the wood burner, you've got a basic sink.
You have to think that the keepers were out at sea for weeks at a time.
Months, I think, yeah. I think some
But they'd have to take everything they needed with
all the provisions.
All the provisions for fuel, food, water.
Yeah, everything, cooking, you know, everything. Because once the boat had left, I suppose.
that could be it for weeks, possibly months before anyone could come and see you again. But it must have been an anxious time out there.
I would have thought so. I think it took a certain calibre of person to come out here and be a lighthouse keeper, I think.
Keepers were different. Other lighthouse keepers, when they got onto the lighthouse, that was their own little world. It was like living in a vertical submarine. Personal hygiene was just sort of, well, I did. I got a bucket of salt water out of the sea and poured it over my head.
I'll tell you what, Jason, you wouldn't want to be too much taller, well, too much taller than I am even. So we're still in living quarters here. Well, here we go. It says it on the wall.
Yeah.
We're in the bedroom. And these cabinets, are these...
They slide, yeah.
These are the beds?
These are the actual beds, yeah.
You wouldn't be able to stretch out. There's no starfishing in a big
No,
bed
you
here.
just literally snuggle up, I think.
Can I try and... Oh, just gonna have a little
Let's
look.
go for it, yeah.
I'm sure there's a technique to this. I won't be mastering it on the first go. Let's have a look. Oh, yeah. Actually, I'll take that back.
Yeah, I bet it's quite cosy though.
That's all right. I can fully stretch out. Ah. A little bit coffin-like, but I'll give it a shot. Night. Oh, wow. Ah. No problem with being awoken by the sunrise in here.
The only privacy you had was in bed and a curtain you drew along to separate you from the other people in the bedroom. It was so small that when you did get out of bed to dress yourself, I personally myself had to open the door to put my hand out the door to get the jumper on and then turn round, do the same thing again.
Oh, yes.
This is the lantern, yeah.
Oh, this is brilliant to see. Oh, this is fantastic. Let's have a look.
This is the highest point of the tower. Yeah, this is where all the action will be with the lighting.
Right, so this, is this these rings were for the candles? These are all
yeah, for the candles,
candelabras?
Yeah. So you, obviously the lighthouse keeper would light the candles every night.
You'd be lighting them, replacing them, checking them, making sure they were still lit. And that's a job, isn't it?
Big responsibility on your shoulders being out there, I should imagine, keep those candles burning.
The lighthouse has got a place in every sailor's heart. And when you're coming home, there's nothing nicer than seeing the landfall and the light looking at you. You can check your position, you can take bearings off it. Beautiful.
Mariners have been guided by a light coming from this one tower night after night for over 130 years. And it's good for at least another 50 years, even with rising sea levels. But it wouldn't be here at all if it weren't for the astonishingly bold and groundbreaking innovations of its predecessors out here on Eddystone Rock.
These structures had to withstand the hardest possible weather. They had to keep safe the men who stoically lived and worked inside them. And the fact that these towers are still surviving is truly remarkable, and a real testament to the skill of their builders.
What is extraordinary about all these people is that it's really heroic what those men did.
It truly stands on the shoulders of giants. The lights of Eddystone Rock have not just inspired countless copies around the world. They've given us one of the most iconic monuments to human endeavour, the Rock Lighthouse.
The Rock Lighthouse, one of the most heroic feats of engineering in maritime history.
You're out there fighting the elements, you're fighting nature on the front line.
Built to save the lives of thousands at sea.
There was a lot of shipping lost.
In the face of catastrophic storms.
The day you turn your back on the sea is the day you're going to die.
So how did they build them?
Whoa!
I'm Rob Bell, and I'm going behind closed doors to uncover staggering tales of innovation, epic adventure.
This is over 300 degrees, this lead I've got in here, right?
And danger. To reveal the secrets of some of the most extraordinary structures ever built. This time, on a deadly reef in one of the most hostile locations on Earth.
I just thought, this is madness.
One man strived to achieve the impossible.
He had an absolute sense of mission.
It was rather like putting man on the moon in the 1960s.
With technological innovation.
It's a wonderful story, actually.
And pure determination.
They were hard-working men.
Still standing after 200 years, it's been described as one of the 7 wonders of the industrial world.
Everybody said, oh, you can't possibly build it, but they did it.
But how did they build the Bell Rock Lighthouse in the fearsome North Sea? Stretching over 11,000 rocky miles, the Scottish coastline may look beautiful, but powerful currents, perilous seas, and sudden storms can easily catch out unwary mariners. not to mention the sharp rocks hidden beneath the waves.
For centuries, this wild coast has condemned thousands of ships and countless sailors to a grim, watery grave in the bitterly cold North Sea.
11 miles offshore lies one of Britain's deadliest reefs. The Bell Rock, a jagged cluster of stubborn sandstone, only visible at low tide, threatened wreck and ruin to all who sailed these waters. Lying on busy shipping routes into Dundee and Edinburgh, it played havoc with trade along the whole east coast. During the 18th century, 6 ships were thought wrecked here every year. These rocks struck horror into the hearts of seamen and were about to claim one of their biggest ever scalps.
In 1804, on a routine North Sea patrol, the 74-gun HMS York was making her way up the east coast when she foundered on the Bell Rock, sinking with the loss of all 491 hands.
After countless other disasters, such a blow to the British Navy couldn't go unaddressed. Angry voices in Parliament demanded something must be done. It was from here, in Arbroath Harbour, that the brave men who signed up to tackle the problem would wave goodbye to the safety of dry land. More than 2 centuries later, the solution they came up with is still standing today.
Wow! Well, they don't come more sea-washed than this.
This reef stretches for 1,400 feet, but much of it is permanently hidden from sight. And at high tide, the whole thing can be 16 feet underwater.
But this lighthouse was completed in 1811, and ever since then it's withstood everything the North Sea has thrown at it. And it's never needed one single stone replacing.
But at the start of the 19th century, building on a submerged reef far out to sea where huge storms destroyed all in their path was considered utterly impossible.
So how did they even start?
In 1804, this desperate problem became one man's chance to make his name by taking on the most daunting challenge of all. Robert Stephenson was a young and ambitious engineer. Still relatively unproven, he was determined to establish that something could be done.
Robert Stephenson, he had an absolute sense of mission and was entirely self-made, but had a brilliant engineering brain, genuinely brilliant.
Stephenson was a rising star who'd overseen construction of his first lighthouse at the tender age of 19.
He was very sure of his abilities. He believed he was put on earth by God to mark this reef.
With the backing of John Rennie, one of Britain's most eminent engineers, Stephenson's wild dream got the go-ahead. As the man in charge of work on the rock itself, he was set to take on the most daunting challenge in the engineering world.
The Bell Rock was the construction that was going to make or break Robert Stephenson's reputation.
But in 1794, when Stephenson persuaded a brave fisherman to bring him out here to the deadly reef, conditions meant that they couldn't even land on the rock, let alone plan how to build a lighthouse.
The biggest challenge of building the Bell Rock is the fact that it disappears with every tide. It was rather like putting man on the moon in the 1960s. It was just doing something that really hadn't been done before.
When work began in 1807, there were only a handful of rock lighthouses in the whole of Britain, and none of those rocks were submerged at high tide. 20 miles off the Welsh coast, the Smalls Lighthouse was built on 9 oak and iron pillars. Stephenson is said to have described it as a raft of timber rudely put together. He did consider a similar design using cast iron pilings, only to reject it for the high maintenance it would require. But 9 miles off the Cornish coast, the Eddystone Lighthouse had been completed in 1759. Its engineer, John Smeaton, had proved a granite stone tower could withstand the harshest storms of the English Channel.
Stevenson was to draw inspiration from both of his predecessors, but building in the North Sea, he knew he'd have to do better.
With nowhere on the rock to take refuge or store materials, Stevenson established a pattern that was to become his hallmark. He engineered a solution. He commissioned a works boat, the Smeaton, named after his hero, the designer of the Eddystone Lighthouse. Anchored off the rock, Stevenson and the men would eat and sleep on the ship, saving dangerous and exhausting trips to shore and back. But life on board wasn't always plain sailing.
These men were sick everywhere. Even Stevenson on occasion was feeling the effects of the sea, and he was very much used to sailing in conditions like that. You can think of the waves coming over the ship as well. It was often getting flooded. It sounds miserable to me to have to be wet when you're at home and wet when you're also working as well.
But life on the reef was no picnic either.
The sandstone on the Bell Rock was both jagged and awkward. It was also spectacularly hard, meaning tools would blunt within minutes, and the progress on foundations was painfully slow.
Stevenson came up with a surreal solution. He brought a blacksmith with him onto the reef.
With a forge and an anvil bolted down to the rock, tools could be sharpened on location. The blacksmith sometimes continuing on at his anvil up to his knees in water.
But the hardness of the rock wasn't their only problem.
As the hole slowly took shape, it would fill with water at every high tide. On every shift, it took a team of 20 men just to pump the hole dry, while another team picked away at the stubborn rock. And even at low tides, frequent large waves would wash right over the reef, filling the hole again.
In order to build something there, you have to get onto the rock at low tide, hammer away frantically, and then jump off when the tide starts to rise. They had to run, literally, to catch the boats before they were drowned. It was as simple as that.
After a close call when a drifting boat left them marooned on the rock with the tide rising fast, it was clear they needed a better solution. But Stevenson had a plan. He would build a temporary barracks on the rock itself. Like the Smalls Lighthouse off Wales, it was raised above the reef on sturdy oak beams to allow the force of the water to pass beneath. This structure could also act as a temporary lighthouse and was known as the Beacon.
Once complete, it was the beacon that would house Stevenson and his men, making it easier to get to work on the rock and provide them somewhere to retreat to for safety if need be.
The team that were on the Bell Rock, they were hard-working men, putting up with difficult and dangerous conditions, happy to climb into that refuge and wait for the tide going down. And in the summer months, they would be working all the daylight hours that were available.
The men endured nervous nights in terrible storms, sheltering in the beacon. But the main lighthouse needed to be a tall tower capable of sending a beam across the sea for decades. And Stevenson's design for that couldn't have been more different. It was to be built of huge granite blocks that could weigh over a ton. As winter approached and the weather worsened, work on the rock was suspended. But Stevenson knew his next problem was to be a Herculean task. How to raise up 1,300 tons of granite on the reef.
To build a stone tower in the middle of the sea.
The Bell Rock Lighthouse has been described as one of the 7 wonders of the industrial world. Robert Stevenson was the resident engineer who oversaw building 11 miles off the coast of Scotland on a jagged reef, submerged at high tide by the stormy North Sea.
Robert Stevenson was an innovator. I mean, he really was at the cutting edge of engineering and wanted to really push the boundaries and prove that he could overcome the elements.
In the second summer of building on the Bell Rock, Stevenson faced a monumental problem: how to move 1-ton blocks of granite into position on a slippery, tide-washed reef.
Each stone had to be unloaded from the Smeaton onto a smaller boat, bobbing around precariously in the waves. Then these massive weights were brought in as close as possible to the reef before being unloaded onto the rock and carried across it to the tower.
Lighthouses were still frequently swept away in high seas. But by locking the stones together with dovetailed joints, each one was anchored by the weight of all the others. Placing them was a laborious, delicate job, and with so little time to work between tides, they desperately needed to speed things up.
When you're out there, you have to figure out a way of making the machinery to make something like the Bell Rock buildable.
Arbroath's Signal Tower Museum was originally the Bell Rock's shore station.
What have we got here, Caroline?
So this is Robert Stevenson's account of the construction of the Bell Rock Lighthouse.
That's really, really exciting. So this is an actual copy from his. This isn't a contemporary copy.
Handwriting as well.
When did he have the time to do all this, considering?
He was a very busy man, yeah.
So what have you got? I mean, this is a whole volume.
Oh, this is incredibly detailed. You can see he's gone into the whole construction of the entire thing.
Stevenson built a standard shear crane on the reef to lift stones out of the pram boats. But getting them onto the rocks was only the start of the challenge. To move the granite blocks safely and efficiently across the jagged, slippery surface, his team constructed an elevated railway on the reef, carrying them from the landing point to the tower's foundations.
What else have we got in it?
Oh, so this is the movable beam crane.
And this was the crane that was out on the Bell Rock itself, was it?
Uh-huh.
The blocks had to be precisely manoeuvred into position as quickly as possible. So Stevenson's team invented the jib arm crane. The adjustable arm and the rotating base made it far more manoeuvrable than existing cranes. But it was supported by guy ropes, and as the tower grew higher, there wasn't enough room on the reef below to anchor them properly. So Stevenson's team simply invented another new crane, and the principle they came up with is still in use on building sites around the world today. The balance crane used a counterweight to balance the load of the stone and could be lifted as high up the tower as building required.
I think the more you delve into it, the more that you see that, Stevenson's hand is all over this. He's this polymath, this Renaissance man, this master of perfection. And that is so clear when you look through this document here.
The rock was a hive of activity, a most pleasing sight for Stevenson, who in the middle of the ocean described the scene as having a very curious and fanciful appearance.
Any non-local sailor coming past here at that time of construction must have had to blink or look twice at what they saw. A group of men out here, seemingly marooned in the middle of the sea, with smoke pouring out of the forge and drifting across the reef. Wagons being shifted around on a small railway, all in the middle of the barren North Sea. It must have been like some kind of crazy mirage.
Having worked out how to get the stones into place, Stevenson's next problem was sealing the joints. Dovetailing held the tower together, but it still needed mortar to stop the sea getting in. And if ice was allowed to form between the granite blocks, it could potentially damage the stone. Back in the 1800s, most building was done with a straightforward lime mortar that would take weeks to fully dry, and out on the reef, there'd be no chance of it setting before it started to wash away. But Stephenson knew of an ancient technology invented by the Romans, its secret ingredient, volcanic ash. At Aberdeen University, Professor Donald McPhee is an expert in the chemistry of cement.
The Romans were credited with quite a lot of engineering successes with cement, and indeed the volcanic ash that we are using today will have the same sort of properties as the volcanic ashes that gave them the opportunity to build marine structures, so harbours and so on.
By heating limestone, you make quicklime, and when you add water, you get a lot of heat.
Now, maybe you can see the water boiling there. This is a reaction called slaking. The thing that's important in terms of those Stephenson cements is that the slaked lime itself is reactive.
And when our volcanic ash is added to the mix, this reactive substance achieves something extraordinary.
In the presence of the aluminium and silicon ions that come from the volcanic ash, there can be other reactions to produce new products that give the long-term durability of the structure as a whole.
This putty-like consistency made it less likely to wash away as the tide rose, and the final mortar, mixed with sand to prevent cracking, would set within a few hours, even underwater. In fact, prolonged exposure to water actually helped this cement grow stronger and harder, making it the perfect material for building in the middle of the ocean.
You know, it's a very challenging environment, and you know, there's an element of excitement about it, which I would probably have loved to have had the opportunity to participate in. I would certainly have applied for a job if I'd been around at the time.
In 1810, after 4 years of work, the final stone was laid on the finely tapered top of the tower.
The tower's shell was complete, but when it came to its light, there was one crucial concern.
Once lighthouses begin to proliferate, you have a real problem about how you tell one from the next. And there had been a famous incident of a big wreck where a ship had sailed towards what they thought was a lighthouse, and it turned out to be a lime kiln.
On a boat in the dark, how could you tell a lighthouse from any other structure? Stephenson knew of a way. He made the Bell Rock Scotland's first ever rotating light. I've come here to the old Kinnaird Head Lighthouse to see how it would have worked. And to give you a clue, walking up these stairs feels like climbing up the inside of a giant grandfather clock.
So what have we got here? What's this?
Well, we're in the light room now, and we have our hyperradial lens and also the machinery which will rotate the lens.
This is what's caught my eye, this beautiful bit of mechanics.
The original ones were actually made by clockmakers in France.
So we've got all these gears and teeth and axles and chains. And are those the chains that we saw on our way up there in the middle as we spiraled around?
Certainly, the chains descend all the way down the tower. They're actually the most important part of the machinery because from those chains a weight is attached and that will pull down on the chains, pull around all the cogs, and that is what rotates the lens.
Is there any chance we can actually get this going here now on the machine?
Oh, certainly, yes.
The descending weight kept the keepers on their toes. It was essential to wind it back up before it reached the bottom, and that had to be done here at least every half hour.
And the weight takes over.
And it doesn't surprise me that you tell me the first mechanisms like this were built by clockmakers, because this was also about precision in making this go around at a precise 30 seconds per rotation. It's all about timing.
It's all about timing.
As more and more lights adopted this system, each one was designated a unique flash pattern. So even at night, mariners could be sure which lighthouse was which.
The lens had to produce a flash every 15 seconds That was the keeper's purpose for being here.
Yep.
So if he can't do that, there was no point in him having his light go round at all.
Yep.
On the 1st of February 1811, the Bell Rock Lighthouse was lit for the first time.
The light actually meant that mariners instantly had a reference, a beacon, and they knew the reef was there. And it was literally night and day in terms of safety.
The Stevenson name was made by the Bell Rock Lighthouse. He became a celebrity overnight. It really cemented the family name as being among the best lighthouse engineers in the world, if not the best.
I mean, what is extraordinary about all these people is that they looked at things like the Bell Rock. Everybody said, oh, you can't possibly build it, but they did it.
The completion of the Bell Rock's construction was far from the end of this iconic lighthouse's engineering innovations.
The Industrial Revolution meant more ships than ever braving these stormy waters. And with unlit rocks still lurking all along this deadly coastline, if more lives were to be saved, Stephenson's light would need radical new technology. The completion of the Bell Rock Lighthouse in 1811 had made Robert Stephenson's reputation.
It took a lot of planning, it took great engineering skills. It is definitely a feat of Scottish engineering.
But with deadly danger all along this coastline, and vast areas of ocean still unlit, Stephenson knew lighthouses needed to do more. The light on the Bell Rock didn't just mark the reef, it also helped mariners fix their position. So it was vital they could see it from as far away as possible. But making the lighthouse more powerful would require a giant leap in technology.
In the early days, the light source in a lighthouse was simple technology. It pretty much followed the kind of lighting you'd find in the home. Candles and oil lamps. The burning question was how to increase their brightness.
Simple reflectors like these, developed from those used on street lamps, had greatly increased the strength of early light sources.
This concave bowl, lined with mirrors, would reflect any light emitted behind or out the sides of this burning wick in the middle here, and redirect it forwards, increasing the power of the lamp in this direction. This meant that a basic oil lamp like this, a flame burning on that wick, could be seen for up to 10 miles, giving a respectable warning to any unwary mariners.
Well, the Bell Rock Lighthouse, of course, is 1811, and the first lighting system would indeed have been very good. Silvered parabolic reflectors with argand lamps. And actually, they were really very, very efficient.
As ever, Stephenson the perfectionist wanted more. And this is the game-changing innovation that revolutionized lighthouses, the Fresnel lens.
Stephenson worked tirelessly on lighthouse development, making frequent research trips to investigate the latest innovations. But what he saw in 1824 was a blinding revelation.
Stephenson went on a fact-finding mission to France, and at the Cordouan Lighthouse on the Atlantic coast, he first saw the technology that would revolutionize the capacity of lights around the world.
The Fresnel brothers had pioneered the use of a lens positioned in front of the light. This early example of their work magnified threefold the power of the beam of this flagship French lighthouse. Over the following decades, Stephenson and his sons helped develop their lenses and introduce them to the Northern Lights. The old Kinnaird Head Lighthouse still boasts a working Fresnel lens. It's been superseded by the automated LED light next door. But they'll be turning it back on for me tonight, so I can see for myself what difference the lens made. We've placed a naked light at the top of the lighthouse.
So that light up there is a bit of a comparison test.
From across the bay, you can see that our bulb isn't nearly as strong as the bright flash of the modern lighthouse's beam. But using a bulb with the same strength as our test light, can the Fresnel lens match that modern technology?
Here it comes. What I'm seeing down here is nothing compared to what the lens is projecting out across the horizon.
The Fresnel lens concentrates the strength of the light by focusing its rays into a sweeping, powerful beam, creating a bright flash as it crosses our vision. That beam is visible from 25 miles away, making it more than a match for the modern light beside it. But how does this lens magnify the power of the light so greatly?
Here, I have a laser. Let's turn that on. Now that single beam represents a single ray of light, which heads off in a very specific direction. And I have here 2 more lasers, which I'm going to set up, heading out in random directions. Let's pop one out there, and this one out here, representing light beams from a light source that are going off in all different directions. But I want them to head out to sea between my 2 goalposts to line up with this laser beam here. So I bring in the prisms. So with my 2 light sources here going through prisms, I've got a more intense light heading in that direction. And in a lighthouse, the Fresnel lens is made up of loads and loads of prisms all around that light source to focus and concentrate the light energy in one direction so that it can be seen for miles and miles heading out to sea.
Robert Stephenson passed away in 1850, but he left behind him a dynasty of talented engineers, and his family continued his remarkable work on the northern lighthouses. But they had a complex new problem. These phenomenal lenses were incredibly heavy. Turning them created enormous friction. Wheels and bearings had to be constantly replaced, and they could only rotate at slow speeds. It was nearly 70 years before a solution was put into practice. And I've come here to the National Maritime Museum of Ireland to see it for myself.
Wow. To come into an old church and be confronted with this. I have seen the light.
Installed at Dublin's Bailey Lighthouse in 1902, this Fresnel lens weighs in at a whopping 10 tons. But that's not actually what I've come here to see.
It's quite hard to take this all in. I mean, you've obviously got the enormous lens on the top up here, but what you can't see in here, which is equally fascinating, is there's a giant donut-shaped trough or basin in here that's filled with mercury. And then the lens is attached to a great big donut-shaped ring, which then sits on top of that mercury.
Nigel Teggin is a volunteer curator here at the museum.
Having invented, really, the Fresnel lens, with that came another problem as to how you were going to manoeuvre this great big weight.
Yes, that's true. So they came up with the idea of floating it in mercury. And in that optic there, we have 25 pints thereabouts of mercury. And
I'm trying to imagine that lined up on a bar, 25 pints of mercury.
Well, you wouldn't carry it very far.
No.
The mercury bath had a twofold advantage. It could carry more weight and turn it more efficiently. Faster rotation allowed flash patterns to speed up, and lighthouses could be recognised far more quickly. Exposure to mercury can cause serious health problems, but under laboratory conditions at Aberdeen University, I'm getting a closer look at what makes it so special.
So tell me a little bit about the properties of mercury. It's a bit of a unique metal, isn't it?
Yeah, it's nearly 14 times as dense as water.
Yeah, that's what I was hoping for. There's a mass to that. You can feel the momentum as you move it. I mean, that is weird because it's so heavy, but it's a liquid. That is so odd.
So as we're pouring it, we will have to be careful and do it quite slowly, just so it doesn't break the bottom of the beaker too, because of the weight.
But its density was only one advantage of this fascinating material.
Another thing that was crucially important for lighthouses was the fact that it was virtually frictionless. Is that true? What makes mercury, what gives mercury that kind of character?
So, first of all, it's a liquid, so there's always going to be the less sort of kind of friction, and it's also got a really high surface tension as well.
Time to compare mercury to water.
So, whichever is most dense will sink. So there we go. The golf ball is denser than water.
Yeah.
I'll steel pellet here. Sinks like a stone.
But how do they behave in mercury?
It's so weird. That is so odd.
Try push it down as well. And
try and push it down?
Yeah, of course, go for it.
And then, I'm not going to let go of it, but it just pops straight back up. Oi.
And now for the same test with the steel pellet.
Oh, wow. Just bobbing away.
Yeah.
Like a toy boat on a lake.
It's quite interesting to see a metal supported by another metal.
You can imagine scaling this up to the size of those mercury troughs they had in the lighthouses, and you could start to understand how they could support tons of weight of that glass on those lenses above.
But mercury is toxic, and interacting with it was another occupational hazard for lighthouse keepers in a difficult and dangerous job.
It's very stressful. If your light goes out, you're likely to have ships run aground. They were absolutely crucial, the lights, keeping navigation safe. And you as the lighthouse keeper, that was the responsibility on your shoulders.
There's no doubt that the lighthouse keepers were a special breed. Psychological fortitude was just one requirement of this phenomenally hard job. Keeping this complex machine in operation night after night, whatever the weather.
But who were the remarkable men who would leave their families behind and sacrifice their liberty for the safety of others? The building of the Bell Rock was no easy task. And once it was finished, it required at least 3 men to maintain the light. Marooned on the rock for weeks, sometimes months at a time, at the mercy of the elements in the cramped confines of a cold stone tower, who on earth would sign up for the job?
The idea of me going for a job as a lighthouse keeper, even my own family said, John, you're the lighthouse keeper, you're mad.
Lighthouse keepers had no control over where they served, and a posting on the Bell Rock was as tough as it came.
The Bell Rock was not a very popular station.
The reputation was, oh, no, the bloody bell.
Just getting onto a rock lighthouse was no easy task.
In the small hours of the winter morning, as I saw these men dressed in their oilskins going into a boat in the black dark, I just thought, this is madness. The men in these boats, this was their life. The mate was in charge of the boat, and when he snapped his fingers, you know, that was how the job was done. Just a look, right, Jim? Right. And that was it. And they knew what they were doing, and they were very, very sharp and good at their job.
And once they were into the lighthouse, things didn't get any easier.
Condition on the Bell compared to other lighthouses was hard. I was very lonely being out there, and a lot of people couldn't stand being locked up. It was like being in a prison. You couldn't go any place.
Psychologist Dr. Sophie Homer has studied the severe impact of solitary confinement.
Now, if we think about solitary confinement, for example, that's considered a punishment for a reason. and studies have shown that it really increases risk of experiencing depression, anxiety, anger. Now, of course, that's an extreme form of isolation, but thinking about our lighthouse keepers, they would have been so removed from their friends, their family and their communities that it really would have been lonely work.
Rock lighthouses, like the Bell, were a far cry from a posting on the mainland.
I mean, if you were at a land station, you were there with your family. In my time, I spent 15 years on rock stations. I never got a Christmas with them in 4 years.
And the keepers had just as little choice when it came to who they served with.
I think we all have certain colleagues at work who we maybe try to avoid, but imagine being stranded effectively with them and confined to very close quarters. I think lots of us would think, no, thank you.
Foreseeing these kinds of problems, Stevenson had devised a way that the men on the lighthouse could communicate with the mainland. A signal tower on the edge of the harbour.
So if we look out to sea here, we can see Bell Rock
just
Lighthouse
there.
out there, just off to the right of that oil rig.
Yes.
How important was this signal tower and the buildings here to the Bell Rock Lighthouse?
It was incredibly important. It was an absolute lifeline. That was their only means of communication back to the shore again.
Does it work? Does this still winch up and down if you need to?
Absolutely, yes, it is still in working order. Would you like to have a go?
I'd love to have a go. Are we getting to movement?
Oh yeah, you can.
There he goes.
It takes a wee while to get started.
So there were 3 messages you could send with this?
Yeah, pretty much.
Everything's fine up the top. No, everything is definitely not fine. Nothing's happening, the ball's down the bottom. But half-mast, raised halfway, that was a specific signal about needing medical attention.
Yeah, that was like, oh, we need a doctor, we need someone to come out straight away.
But that expected communication between the tower and the lighthouse, that was what, only once a day that would happen at a set time?
Yeah.
So what would happen if something happened out on the lighthouse during the day that they needed to alert the tower about?
So they had a flagpole on here as well, and Stevenson devised this amazing book that had various different flags and means of communicating with the keepers on land. But one of the less official ways that the flagpole was used was that obviously a keeper would be on the Bell Rock, no communication with the land and his family. If his wife was expecting a baby and she had the baby while he was on the lighthouse, he wouldn't know whether it was a boy or a girl. So to let him know, they'd raise either a little pair of trousers or a petticoat on the flagpole so he could look over and see whether his wife had had a boy or a girl.
Seriously, that was the kind of communication that could happen?
Yeah, and it's such a lovely personal thing.
That's really nice.
Despite frequent periods of isolation, for the men who could stick it out, being a lighthouse keeper was a job like no other.
I've got very fond memories of the Bell. I enjoyed my time out on the Bell. I used to lie there and watch the stars, and you can hear the thump, thump, thump of the ships going through, you know, struggling against the tide. And you can see the beam going round and round, and you just lie there. Oh.
After giving 32 years of my life to the Lighthouse Service, did I ever feel that I was doing a worthwhile job? Yes. The motto of the Lighthouse Service, in salutem omnium, for the safety of all. That was what we lived for.
The last lighthouse keeper left their post in 1998 as automation took over. But the lighthouses are still as important as ever.
So the Northern Lighthouse Board today is doing pretty much the same job that it was in 1786. We are here to protect the lives of mariners and to provide safe navigation. Although there's GPS, it's rather like driving a car. We still need curbstones and traffic signs to keep the driver safe. It's the same at sea. The mariner still needs a visual reference to look out the window and just that final check about where they are.
And Stevenson's legacy remains just as important as the lighthouses he built.
Stevenson was a great leader. It was, the Bell Rock and its keepers that came beyond really set the pace for the way we are today.
For Stevenson to have the original vision to do it, and for Stevenson to be the man on the reef most days to see it carried out, I think he deserves a lot of credit for doing that.
Now the world's oldest sea-washed lighthouse, with every passing year, the building of the Bell Rock becomes an ever more phenomenal achievement. The innovation and industry that built this tower also provided a blueprint for generations of engineers, which, like this lighthouse, continues to stand the test of time.
There's something very inspiring about the fact that these men went out to these places of huge darkness in order to raise a light to save lives. That's the best of us, that's the best of humanity.
The Rock Lighthouse, one of the most heroic feats of engineering in maritime history.
You're out there fighting the elements, you're fighting nature on the front line.
Built to save the lives of thousands at sea.
There was a lot of shipping lost.
In the face of catastrophic storms.
The day you turn your back on the sea is the day you're going to die.
So how did they build them? Whoa! I'm Rob Bell, and I'm going behind closed doors to uncover staggering tales of innovation, epic adventure.
This is over 300 degrees, this lead I've got in here, right?
And danger. To reveal the secrets of some of the most extraordinary structures ever built. This time, Ireland's guardian of the Atlantic.
It's the last of the great rock lighthouses.
Built in terrible conditions that engineering struggled to conquer.
I stood here and I was afraid the dome would come off.
But today it stands as a beacon of scientific progress.
It might not look like it, but this is man-made lightning right here.
It's quite exciting.
The Fastnet Rock Lighthouse. The Atlantic Ocean, one of the most dangerous bodies of water in the world. And once mariners cross these seas, they're faced with yet another challenge. The jagged southwest coast of Ireland. Because of these dangers, lighthouse keeping has a long tradition in this part of the world. And it's all thanks to a man of faith.
In the 5th century, here in County Wexford, a monk called Duvan started lighting fires at the mouth of the bay so boats could safely find their way in.
For the last 1,500 years, there's always been a light here. In the 19th century, dozens of lighthouses were built around the coast of the Emerald Isle. In 1848, it was decided that a new beacon was needed to protect valuable transatlantic shipping. It was built 8 miles out to sea, on Ireland's most southerly point, Fastnet Rock.
Ever since sailors first ventured out there, the origins of its name spoke for themselves. In Old Norse, it's said to mean sharp tooth, and in Gaelic, lonely rock.
Even before the lighthouse was built, the sight of this iconic rock has stirred up strong feelings for seafarers for generations. Whether they were returning to the safety of home or leaving for good. Fastnet is practically seared into the consciousness of the Irish around the world, because over 3,000 miles out to the west is New York.
And in 1847, the potato famine triggered mass migration from Ireland to America. And that rock, seemingly dangling off the tip of the country as it faces the New World, earned a new name, Ireland's Teardrop, as it was the last sight of the motherland for the thousands of people fleeing poverty, persecution and starvation for a new life.
So how do you go about building a lighthouse on a small, jagged rock 8 miles out to sea? An easy building material would have been brick. But the Fastnet's designer, George Halpin, knew that the mortar between the bricks wouldn't stand up to the battering of the sea. For this one, he was happy to go back to the drawing board.
There wasn't much the Victorians enjoyed more than a good old engineering challenge. And the first idea for that storm-lashed rock was to deploy the go-to building material in the 19th century, iron.
Across Europe, iron was so useful they built everything from it, from the magnificent Crystal Palace to the tallest building of its day, the Eiffel Tower.
One of the great attractions of iron is not only that it's incredibly strong, but that iron plates can be firmly riveted together to form a watertight seal. The very first ship to be made entirely from iron, Brunel's SS Great Britain, transformed the world of shipbuilding. So if an iron ship can withstand the Atlantic Ocean, why can't an iron lighthouse?
George Halpin's bright idea was to use brick and iron together.
Let's get that up there. So this just shows basically the principle of how the lighthouse was built. You've got your simple brick tower on the inside, but then surrounded by these iron plates. This formed an armour-plated base around the bottom half of the lighthouse, which took most of the punishment from the waves. And for a while, it worked.
But what sort of conditions did the tower have to endure? Gerald Butler was one of the Fastnet's last keepers before it was automated in 1989.
It's gorgeous.
He's now attendant keeper of nearby Galley Head Lighthouse. But despite it being on dry land, it still has to face terrible Atlantic storms. Gerald has agreed to give me a privileged peek behind closed doors.
This is the glaring monster.
Oh, I mean, you can look out there and see it's choppy, you know, it's fairly stormy up here today, and you can hear the wind, but how does this compare to some of the conditions you've experienced when you've been out working in lighthouses?
Here, we had a storm there a few years ago, and the waves were breaking just outside of that Smeaton rock there, and they were going right over the top of the lighthouse.
Unbelievable. I cannot imagine what that looks like.
I stood here and I actually got a bit afraid here, so I left the lantern. I was afraid that the dome would come off. I've never seen the wind quite so strong as it was that night.
It almost feels like Mother Nature always throws surprises at us.
It does, and we just have to say that one day Mother Nature is going to win.
The iron and brick Fastnet Lighthouse was completed in 1854. But 28 years later, disaster struck. On the 26th of November 1881, a furious storm lashed the Irish coast. The Fastnet's lantern was smashed and the lens was damaged. But this was trifling compared to the carnage that unfolded at a similar iron and brick tower. The nearby Calf Rock Lighthouse was snapped in half.
terrified keepers managed to survive for 12 days before the storm subsided enough for them to be rescued.
The lighthouse was totally wrecked, but miraculously, all 6 of its keepers survived. After the catastrophe on Calf Rock, the authorities lost all faith in the iron and brick design. It was decided that a new lighthouse had to be built on Fastnet, and a more resilient material was needed, one that could stand for generations. They aimed high, literally, and created what is still the tallest lighthouse in the British Isles.
But this gargantuan struggle could have been for nothing, were it not for people capable of levels of endurance and tenacity that beggar belief. The story of Fastnet's builders and keepers is a monument to human achievement.
And one man takes the credit of raising the tower that still stands to this day. The Fastnet Lighthouse. Standing strong for over a century, this tower has taken everything the Atlantic has thrown at it. After the demise of the nearby Calf Rock Lighthouse in 1881, it was clear that iron and brick wouldn't stand up to the elements. To construct a tower that would last, its designer, William Douglas, decided to build in stone. But working with masses of stone on this tiny island would be a huge task. And for a huge task, you need a huge character. That man was James Kavanagh.
This picture is a rare glimpse of James Kavanagh there stopping work to pose for a photograph on the tower. As foreman, he personally set every single one of Fastnet's 2,047 blocks by hand. And somewhere on Fastnet Rock is a cave known as Kavanagh's Hole, named so because he was so hell-bent on perfecting Fastnets, he'd sometimes spend the night in the cave. Kavanagh refused to leave the rock at all as long as work was going on, and that was for 7 years.
The lighthouse has a degree of perfection which could only have resulted from one person having completely innate supervision of its entire construction, and that was James Kavanagh. He's always distinguishable because he's wearing a pristine white jacket, and quite how he kept it clean on this quite difficult building site, God only knows. He organised and ran his men with a sort of stern, almost military efficiency, but, you know, despite the extreme difficulty and the very dangerous job that was being done. Fastnet was remarkable for the fact that there were no fatalities.
To better understand the challenges faced by Kavanagh and his crew, I'm meeting with Owen Lehane from Irish Lights, who manage all of Ireland's lighthouses.
Is this an original drawing, do we know?
These are dating from 1904. These have been hand-drawn at the time.
It just goes to show the challenge it must have been to decide where and how to build on this rock.
Absolutely. Fastnet Rock is literally a pinnacle of rock sitting in the middle of the Atlantic Ocean, subject to all of the storms that the North Atlantic can throw you. I mean, they did this without any knowledge of what we would term today as our wave loadings, our sea rises, our climate change.
Wow.
Quarrying and transporting enough stone to build a lighthouse can be hugely expensive, so it made sense to use what's locally available. But in Southern Ireland, the landscape is mainly made of white limestone and red sandstone, rocks that might not take the pounding of the Atlantic. So the Fastnet's designers looked at previous rock lighthouses. They were built from much stronger stuff, granite. It's time for me to take a look at the difference between sandstone and granite myself.
Now, I'm keen to try out my own highly scientific test. This is the best I can do. Let's try this sandstone first. It never stood a chance. Okay, so now let's try granite. Ha ha! Right, I'll give that a bit more beans. The hammer's almost bouncing back off it. Unbelievable. Well, based on the results from my experiment, granite it is.
And indeed, in 1897, Kavanagh and his team took receipt of the first batch of what would ultimately be 4,300 tons of Cornish granite. But he knew that these blocks couldn't just be stacked up one on top of each other like a wall. It would collapse as soon as the first storm hit. Other stone lighthouses that predated the Fastnet used different methods to get around this issue.
The Fastnet is the last of the great rock lighthouses completed in 1904, and probably the most perfect of them, mainly because all of the lessons in rock lighthouse building had by then been learned.
At the Eddystone Lighthouse in Cornwall, designer John Smeaton had pioneered a technique more commonly found in carpentry, dovetailing. Every block was cut so that it interlocked perfectly with the ones around it. But at the Fastnet, they went even further. The first 10 courses of stone were built into the solid rock it sits on, and each block in the tower was dovetailed on every side, so it slotted snugly in with its neighbours above and below. Jeff McCarthy is another of the Fastnet's veteran crew.
Well, I'm standing beside a lump of granite now. It's 3 tons in weight, and it is an exact replica of one of the 2,074 stones that were quarried in Cornwall and shipped over to Ireland to construct the Fastnet. Each one of these, as you can see, it's dovetailed at the top, at the sides, and at the end. It has been reported that there's up to a 2-metre sway at the top of the lighthouse under full pressure of a wave, and being aboard the lighthouse, the whole unit moves as one. It's like a palm tree almost.
Despite the Fastnet's ability to shrug off the most terrifying waves, sheltering inside could still be a pretty hair-raising experience for its keepers.
During every storm, there is always what we might term a rogue wave. I have seen it, this massive explosion of water all around us. I was standing inside in the centre of the lighthouse, holding onto the kitchen sink, and I had to put my foot out to correct my balance. Water came in every little peephole it could, up through the kitchen sink. I wasn't afraid, I was young, and I always believed that fear goes with age, or let's say maturity.
The expertly laid and dovetailed Fastnet Tower was topped out in 1903. But James Kavanagh didn't live to see its lantern lit.
Kavanagh finally bade farewell to Fastnet Rock in June 1903. Just a month later, he died suddenly from a stroke. Now, this humble engineer may not be as famous or celebrated as his towering creation, but for me, the obvious passion and determination that he poured into building this structure make James Kavanagh a giant of the engineering world.
A year after Kavanagh's death, the Fastnet's lamp was lit on the 27th of June, 1904. But before the Fastnet, lantern technology was rudimentary. Candles and simple oil lamps were the main methods for keeping mariners safe. These low-powered lamps had to be constantly cleaned and maintained to make sure they didn't snuff themselves out. But all that was about to change with the discovery of electricity. Cornishman Humphrey Davy was one of Britain's first electrical pioneers. In the first decade of the 1800s, Davy demonstrated what he called the carbon arc lamp. Something that would have been an incredible sight in his dim, candle-lit lab. Struan Simpson is a PhD student at Aberdeen University, and he's going to show me how these arc lamps worked.
What is an electric arc exactly?
So an electric arc is the jumping of electricity from one point to another. So it was almost like we were kind of creating lightning in our own way and using that to light up our environments.
Can we see how that would have worked?
Sure. We've got these carbon rods. We're going to attach these to a crocodile clip and then push them together. It's actually contacting the carbon rods together that will complete that circuit. And that's what's going to give us our arc.
And why do we need carbon?
Carbon is quite essential to forming the actual electric discharge. So when you put the carbon rods together, what actually happens is you produce a flame between the carbon.
Well, let's see it in action. Yeah, there it is. Oh, it's bright.
It is quite bright, yes.
This is what the early arc lamps were, that discovery of the electric arc.
I mean, it might not look like it, but this is man-made lightning right here.
Absolutely, absolutely. Behold.
Although it looks impressive, these batteries only add up to 24 volts.
With absolutely no offence, this is on quite a small scale, though.
It is indeed, yes.
Can we ramp things up a little bit?
Well, of course we can. Here is we've got a power amplifier. Now that will take our mains voltage of 240 volts and push that right up to 2000 volts. Goggles on, yep.
Very good.
So I'll plug this into the amplifier.
It's quite exciting.
There we go.
There's current. Ah! Ah!
And I'll pull them apart.
Wow, that is so bright. Yeah. The amount of energy that's coming out of there is unreal. That is an incredibly bright light. Even though I've got these on, you can hear it buzzing. That's another indication of the power and the energy in there. But I can feel the heat. Having a light source with this much intensity, this much power, compared to what it was beforehand, candles and oil lamps. It's chalk and cheese.
Absolutely, yep.
This was an absolute game changer. Incredible. This amazing new technology should have been a real step forward for lighthouses. But in the early 19th century, arc lamps were powered by batteries. These huge batteries had the potential to save ships, but in doing so, might have killed their keepers. They were full of dangerous chemicals and therefore far from ideal for use in a lighthouse. Could anyone come up with a solution?
Step up the scientific advisor to Trinity House, the institution that manages English and Welsh lighthouses. His name, Michael Faraday.
Faraday was one of the most respected minds of the Victorian era. But to test the arc lamp, his choice of laboratory was a little unusual. South Foreland Lighthouse in Kent.
The main experiments that Faraday undertook at the South Foreland Lighthouse for Trinity House was exploring the feasibility and the practicality of using electric light from batteries. The trouble is, batteries in those days were enormous, full of acids, which produced pretty noxious fumes, and it really just didn't work.
Faraday decided that instead of batteries, he would apply his own theory, electromagnetic induction.
Faraday discovered that if you had a coil of wire like that, and you passed a magnet through it, you generated a current. That's precisely the principle in which all electricity to this day is generated.
At South Foreland, Faraday installed the first large-scale electric generator in the world.
This is really quite an extraordinary thing to do because it's really the first practical application of electric power on a big scale.
Faraday's pioneering work in lighthouse design paved the way for the mass generation of electricity we still enjoy today. And when his generator first ran in 1859, the arc lamp was so powerful it could easily be seen across the Channel in France. A very welcome sight for mariners navigating these troubled waters.
We'll never know how many lives have been saved by lighthouses like Fastnet over the last 200 years. But that's not all we have to be thankful to them for. As progress through the 20th century gathered pace, lighthouses were right there, always driving groundbreaking engineering forwards. But despite all the advances in technology, tragedy was still to come.
The Fastnet Lighthouse. A beacon in the darkness that's been saving lives in the Atlantic for over a century. But before there was a lighthouse here, this stretch of coast was witness to tragedy. The 10th of November, 1847. Thick fog blanketed the shoreline. The sail ship Stephen Whitney slid across the waves, full of passengers, bound for Liverpool. The captain was looking for the old Cape Clear lighthouse, but its lantern was invisible in the fog. Lost and blind, the Stephen Whitney ploughed straight into the rocks of West Calf Island.
Out of the 110 crew and passengers aboard, only 18 survived.
The lives lost on the Stephen Whitney could have been saved had the captain heard a foghorn.
Fog is one of the great fears of seafaring, because once your ship is enveloped in fog, you're completely blind. You don't know where you're going. If a light can't penetrate the fog that surrounds it, then it's worse than useless.
We all know what a foghorn sounds like, right? It's something like this. Nowadays, that classic mournful sound of a gigantic horn has been replaced by more energy-efficient, electronically synthesized tones. But how did early lighthouse keepers meet the challenge of making a noise that could be heard for miles?
To understand more about early foghorn technology, I've come to meet Nigel Teggin at the National Maritime Museum of Ireland in Dún Laoghaire.
This is a hand crank fog signal used on sailing ships in the old days. You should give it a go. We're just big kids, aren't we?
That is not the sound I was expecting to come out of a fog signal. This is a genuine fog signal.
That's a genuine fog signal. Normally used, it would have been used in sailing ships.
Used on ships, but also used on lighthouses?
Yes, well, originally they would have used guns, because every ship in the old days, in sailing ship days, would have been armed. So if a ship was approaching port, it would fire a gun and expect the gun on the lighthouse to fire back at them. They went on to use bells, and then they used explosive fog signals, which basically throwing a banger out the window. What they used to do is rig it up in an apparatus and hold it out to a safe distance and then set it off at regular intervals.
Something like this is part of that great big family of fog signals that have hopefully been keeping mariners safe for centuries.
That's right.
Well, I can't give myself, if I don't have one more go, just to, as a parting part. That doesn't get annoying after a while, does it?
It beggars belief that before foghorns, lighthouse keepers had to use something as dangerous as explosives to warn ships. To find out how on earth this was achieved without blowing themselves to pieces, I've come to meet Dr. Roy Lowry of the University of Plymouth.
What might an explosive fog signal on a lighthouse have looked like?
It would be pretty small, but in those days, it would have been fired manually. So it would have a fuse out the top and you'd light that, and then you'd run away. So you use a small amount of explosive to carry a noise through the fog. You use something called tonite.
That's a form of explosive, is it?
Yeah, its name gives it away. It's from the Latin to mean it thunders. So it's really loud.
You don't want large explosions that can move things when you're surrounded by a load of glass.
Exactly, you're in a very confined space.
I understand that we can experience an explosive fog signal today, right?
Yeah. Not actual tonite, but something very similar. And it's one of these.
That's it?
Yeah.
It's like a party popper.
Yeah, it's one heck of a pop. And there's only about 4 grams of material in there. And if you've ever gone to a concert at Wembley where there was a loud bang in a finale,
yeah,
you've heard one of these.
Wow. Can we demonstrate? Can we hear how loud a blast from a charge this size is going to be?
Why not? Let's do it.
All right, lovely. I will let you do your bit up there. I'll stay out of your way. I'm not quite sure what to expect, how loud a bang to expect here, and I'm quite excited by that, I think.
We're ready to go, except you need a pair of these.
Good, yes, thank you for that. Oh, this looks good.
Testing.
Look at that arm. Click.
3, 2, 1.
I'm so thankful for these.
So you want to be about really short?
Yeah, so sharp and intense.
And really carries well. Use in lighthouses, you want something sharp.
The Fastnet started using an explosive fog signal in 1883. The explosive it used was gun cotton, also known as cotton powder. Irish Lights continued to use this on some lighthouses until the 1970s.
The cotton powder was very volatile. A lot of keepers had their fingers blown off using this stuff. During the War of Independence here, most of the lighthouses were raided by the IRA. The cotton powder charges were taken, and a lot of the fog signals had to be discontinued until the country settled down again.
Once fog signals were mechanised, there was no need for dangerous explosives. And the mournful sound of the foghorn echoed over the waves for much of the 20th century. But what made that sound in particular so successful?
Foghorns play on an interesting piece of science when it comes to making their sound travel for as long a distance as possible. Because it's not just about how loud they are, it's also about which note they play. I stood here, directly in front of the band here. I can hear all 3 instruments very, very clearly. All of them are playing at pretty much the same volume, and it gives you this nice, balanced tune.
The instruments this band are playing are both high-pitched, the banjo, and low-pitched, the drums.
So I've come a little distance down to here, and I can still hear the band playing quite nicely there. And they're still playing the same volume, but the distance has changed the sound somewhat. It feels a little bit thinned out. Let's get further away, see what happens then.
Each instrument plays in its own range of frequencies. The banjo has high notes, but nothing low. The drum, however, is very, very low.
Right, well, coming all the way back here, that's changed everything. I can still hear the low, thumping sounds of the drums, but the higher notes of the banjo, I can't really hear them.
That's because the high-pitched notes that the banjo is pushing through the air are all high frequency, meaning that they travel via lots of short sound waves.
So those higher pitched sounds coming from the banjo have pretty much lost all their energy. They've run out of steam before they even get to me. And that's why if you stand outside of a nightclub on a busy Friday night, pretty much all you can hear are the deep thuds of the beats and the low vibrations from the bass. And that's also why foghorns play out at such a low sound.
Thanks to the advances of the 20th century, keepers on rocks like the Fastnet witness fewer and fewer maritime disasters. But lighthouse technology was helpless against what was about to happen in 1979. The hundreds of competitors running the Fastnet yacht race used the lighthouse as their turning point. But on the 13th of August 1979, some of them never returned. Gerald Butler was serving on the Fastnet when the world-famous race had its darkest hour.
It was a summer storm, and it was awful to be listening to these yachts and they calling for help, and they unable to do anything for themselves or unable to do anything for the yacht beside them either, because any slowing down of your progress left you in a position that you could be capsized yourself. And a lot of the yachts were losing their rudders. Without the rudder, the yacht was helpless. The water was pressing these yachts down into the sea. They were up to their knees in water on top of the decks of the yacht.
Gerald and the keepers on the Fastnet manned the radio and kept tally of which boats rounded the rock, so the Coast Guard knew which yachts were missing.
A yacht would come on and they would say, we've passed another yacht completely inverted, upside down, and no sign of life at all on it. We knew very well that this was going to turn out to be a terrible tragedy. We knew there was going to be a lot of people lost. We really hadn't an idea how many people or what the outcome was going to be.
The rescue effort became one of the biggest ever mounted in peacetime.
4,000 different rescuers came in on the scene. The Dutch Navy were out, the Royal Navy were out, RAF helicopters were flying. It turned out that ultimately 15 competitors were lost.
But if Gerald Butler and the keepers of the Fastnet hadn't been on station, many more lives might have been lost. The Fastnet's light still shines today, just as it did in 1979. However, 10 years after the disaster, new technology would change this lighthouse forever. The Fastnet Lighthouse, a 116-year-old engineering marvel that saved countless lives.
Lighthouses have been at the forefront of technology, if not the actual driving force behind so many scientific advances that are not just useful in the wider world, they're part of our everyday lives. So what next for lighthouses? What's their place in the 21st century?
The Fastnet was fully automated in 1989 and finally bade farewell to its last keeper. But Irish Light still maintains the tower to ensure its beacon shines for all shipping to sea. Owen Lehane can help to shed some light on how much the Fastnet has changed.
This is a 1,000-watt high-energy discharge lamp.
1,000 watts?
Yes. This is the type of light source that was in the old lens on the Fastnet. And the type of LED rotating beacon that's now sitting on top of the dome at Fastnet. This is your version of these lights. This is the lens.
Yep.
If you look into the lens, you will see yellow dot.
Is that a single LED? That's it?
That's what you're looking at through there. That's a single LED, 3 watts, with the lens, giving you 18-mile range.
This replaces that lamp with the enormous lens.
Correct. The entirety of the assembly is only about 30 watts in total.
Goodness me. A fraction of that one lamp
fraction.
There. The technology behind these lamps is constantly progressing and moving forwards.
Yes.
Another way lighthouses are changing is that they're getting smaller and more numerous, in the form of the humble light buoy. I'm meeting Anthony Carey at Irish Light's headquarters to see how these buoys help to keep mariners safe in the 21st century.
We're constantly looking at new ways, new technology, and always, incorporating new engineering into what we're doing. And we're working on an 8-year cycle.
What is it that limits the life of this to 8 years before it needs attention?
It's just the environment that they're in. So these guys right out into the Atlantic Ocean. But when we put this out there, we really don't want it to fail.
The most important feature of these buoys is the lantern.
This is self-contained lanterns. So you can see this got solar panels on it. So during the day, this guy here will charge up the batteries on the inside. And then at night time, it will flash. You can see this is a red. So this guy will flash a red passion of light.
Oh. Yeah, that's a lot heavier than I thought that was gonna be.
I have the privilege of topping out my very own mini lighthouse by attaching the lantern to this buoy.
All right, got my first bolt there. I'm somewhat feeling a little bit of pressure here. Feels like there might be consequences if I don't get this right. Well, I think that is nice and firmly on there.
Absolutely.
So what we've attached here, does that replace everything that's inside that day mark there?
Pretty much will do, yeah. Pretty much everything, as you can see, it's got the solar panels inside, it's charging up the batteries, and it's got its own lantern inside. And it'll transmit back that information through social media, through Twitter, and then we can react to that quicker. So if it's failed, we can put a plan in place then to come and repair that as quickly as possible.
These are smart buoys, if you like.
Smart buoys, yeah, Met buoys, yeah.
Wow, it's just, I mean, ever since lighthouses have existed, it's just this continuation of progress, isn't it?
Yeah.
So, in the age of electronic navigation and light buoys that tweet, a lighthouse is part of our future.
We have gone to GPS, but if onboard equipment fails with smaller craft, they are going to be thankful to have the light there.
Lighthouses would be considered in the category of visual aids to navigation, but the visual aids to navigation are still going to be required for the next 20, 30 years at a minimum.
There is a kind of magic to lighthouses. These unbelievably sophisticated and beautiful towers, which still work today, still do the job that they were supposed to do, represent a light in the dark.
Our seas are probably some of the safest in the world as a result of the efforts of these incredible people over the last few centuries.
So, the next time you go by a lighthouse, just give it a little nod for all the people and the lives that have been saved because it is a lighthouse.
The Fastnet represents the end of an era, the culmination of decades of innovation, and the masterpiece of stone lighthouse building in the British Isles.
Lighthouses have been the driving force behind so many huge leaps in science and technology. And to me, as an engineer, these seemingly simple structures are such powerful symbols of progress. But to the countless generations of mariners who've been kept safe at sea by the people who raise these lights in the darkness, a world without them is simply unimaginable.